Chapter 5. Oh, chapter 4, sorry. I don't have spare paper. Ian, you've been needing spare paper for like a week and a half now. Why haven't you bought an exercise book? Do you want me to call your mum to get that sorted? You sure? Alright, Monday. If I don't see it, I'm going to call your mum. Is that a fair call? Alright, year 11s, let's begin. Quiet down. Here we go, let's do a bit of a recap. Last session, mainly I just want you to look at the notation and read it, because that's what exercise 5A, 5B was about. It's about reading the set notation and then understanding how the domain affects the graph. That's part 5B. 5C is then you're going to use that to then look at what a function is. You have to be able to read the domain and range for that and describe it. Okay, so that's why it is important to be able to read what they're asking. So let's have a look again. What do these braces mean again? Let's go with F. Let's have a look at F. What do these braces mean? When do you use them? In the set of means it's a group of. Okay, so in this case I'm saying I've got a group of. What does the x, comma, y in brackets mean? Can I please have, yes, Seb? Coordinates? Yeah, it just means in this group of coordinates. So I've got a set of coordinates. Okay, and these coordinates follow this equation. Now this equation, what kind of equation do I have here? What's y equals x squared minus 2? What kind of equation do I have there, Anne? What's the name of this equation? Quadratic. It is quadratic. How do we know it's quadratic? The square. Okay, the highest power is to the power of 2. So we know this is quadratic. It's a quadratic equation. We know it's a quadratic equation. And then the second part is this. What does x and this e mean again? What does that e represent? Is kind of equal to, a part of. The name for it is element, that E, kind of looking thing. Member of. Element or member of means a part of. So this X belongs to, or is a member of, or is a part of -1 to 2. What does that mean? What's a -1 with closed brackets to 2 closed brackets mean, Hamish?
That it is including -1 and -2.
Yeah, so that means on your x-axis, you are including from -1 to +2, it's inclusive. That's your domain. That's what they're telling you. They're saying that the domain x, you're already only working between -1 and 2. Anything less than -1, you're not going to have part of the graph. Anything more than 2, you're not going to have part of the graph. Now what's the graph? X squared minus 2. Anyone remember what x squared minus 2 looks like? What does the minus 2 do? Yeah, it goes up, down. A quadratic graph just simply looks like that. It's a parabolic shape. It's a positive shape. It's a smiley shape. So now if it's gone down by 2, instead of it looking like this, it now looks like this. Gone down by 2, and it's going to go up, and it's going to go up. But the difference is, normally when you draw your quadratic shape, it goes all the way infinitely up. But that's only because you have x coordinates that include it. We stop at -1 and we stop at 2. At -1 we stop, and at 2 we stop as well. So in this case here, when x is -1, what's my y value? What's the coordinate when x is -1? So I want to know at -1, if I put -1 into the equation, what would my y be? -1. So that tells me when x is -1, I have a coordinate at -1. At x equals 2, if I sub 2 into the equation to find out what my y coordinate is, and this is when -1 is -1, what would it be when x is 2? 2, because 2 squared is 4, 4 minus 2 is 2, so 2 is over here. This is where 2, 2 is. So that means my quadratic graph no longer continues on, it stops. At -1, I stop there because that's as far as I go, and at 2, I stop here. It doesn't continue on, it doesn't continue on. This is what part B was. So now if you look at this graph here, the domain was -1 to 2. What's my range? What's my maximum y value and my minimum y value? What's my range? Where's it between? Finn? What's my range in this graph here? Yeah, -2 is the lowest value. I'm going to highlight it so you can see. It is from -2 all the way to 2. This is my range. My graph doesn't go beyond that. My graph doesn't go beyond 2, and my graph doesn't go below -2. That's as far as it goes. So that's my minimum. So my range, if you want to write your range, the symbols you would use is you would say it is, you would say it is, why can't I get my pen? Pen, blue. Y is the element for range. It is a member of, and we can say it's from -2 to 2. That's your range. Okay, so that's exercise 5B. That's just the recap. Okay, so that's what I expect you to do for next week, 5A, 5B. We're doing 5C today. Easy? Okay, and remember I did say I'm going to be checking your homework 4A or chapter 4 today. If you haven't done it, you can't tick it off. You promised me it was on a Monday, then a Tuesday, and I said I gave you till Friday. You don't get it done, it's after school. Yeah? After school you stay back and you get that done. All right, here we go. Let's do 5C. I want you to copy these notes. 5C. What is a function? So I mentioned about a function. What is a function? Here we go. Copy these notes down. What is a function? You first need to know what a relation is. So write this down. You got terminology, the term relation. Relation is a set or group of coordinates. Okay, that's it. That's as simple as it is. Any group of coordinates is called a relation. You can have any kind of coordinates. Doesn't matter what kind of coordinates. You can have 2 coordinates if you want. You can have 1, 1 and 2, 0 if you wanted. And that's a set of coordinates. That's called a relation. Okay? You can have all kinds of coordinates. You can have only even coordinates. You can have 2, 0, 4, 0. You can have 6, 0. A group of coordinates makes it a relation. Okay? But when you have a specific type of coordinates or list of group of coordinates where it has something special about it, we call it a function. Now I'll tell you what's special about it. A function, by definition, I've drawn a picture for you to sort of understand it. A function can only have one thing. You must only have one y value, one unique y value. Okay, so that's what I want you to write down. A function is when you only have one unique y coordinate in the group. Meaning that you can have lots of groups, but for all of them, there's always a different y value. You never get a repeated y value. Okay? If you have 2 y values there, then it is still a function, but then you got to look at, well, I only want one y value. I don't want 2. Yeah? So what I mean by this is, and this is sort of a way to describe it, you can have any machine that a function, okay, think of a function as a machine. Doesn't matter what number you put in, x could be 1, x could be 2, as long as the machine only spits out one value. Okay? Then that is a function. So what's an example? Let's think about all the functions you've learnt since year 9. You learnt a linear function, y equals 2x plus, I'll just go y equals 2x, right? Think about this one. If I sub in x equals 1 into this linear function, what do I get? 2, so it spits out y equals 2. If I put in x equals 2, y becomes 4. So that's my machine. My machine spits out only one y value. But check this one out. If I change my equation to root of x, now if I said I put in a 4, root of 4 gives me 2. But not only that, you know that it could be also -2. When you square root a number, it can be either +2 or root, which is -2. Yeah, so you can have either one. Now here's the problem. See, when I sub in a 4, I only put one value in, I get 2 values out. And these are 2 y values. If I put the coordinates for you to see, when x equals 4, you get positive 2, which is 4, 2, or you have negative 2. This is not a function. This is why when you type in the square root in your calculator, they only sketch functions, and that's why it only sketches the top half, because you called it a square root function. But, this is, yeah. But in this case here, because we know square root should have a plus and a minus, the real graph of a square root should actually look like this. That's called a square root relation. That's why when you guys asked me when we're doing the solving and we had the 2 answers for the x-intercepts, the reason why that happened, because you were working with a function. Okay, you're working with a function, and it is possible you can get 2 points, but it is not a function if you have the top and bottom. You only can consider the top or the bottom. Same thing with your circles. See, if you type in your calculator, you can only type in the top half and then the bottom half. The reason why is because there's a positive and a negative version. And as soon as you have 2 of these same y values, you have 2 y values for only 1 x value, that becomes a problem. And this is where it gets tricky. Okay, for those things to understand a function. So in a nutshell, if you can put any x values in, as long as it spits out 1 y value, that's called a function. So even quadratics. So you can put in x equals 1 and x squared is 1. You can put a negative 1 in and it still equals 2. 1. You only get 1 y value, you don't get 2. As soon as you get 2, it's not a function. It's called a relation.
Is there a way to decide which side goes? Or does the calculator just automatically do the top?
Yeah. And if you want to change that
question with that, where it says the plus or the minus, that's how you decide which one, or do you just sort of assume that's going to be the top one?
Yeah, so if they're given in your textbook and they call it a function, which everything in the methods year 11 course is currently a function, not a relation, then it's whatever the sign has, you take that assumption. So in this case here, there'll be a positive root. But as a general, square root itself has a plus and a minus, and it should be a relation. But as soon as you call it a function, then it can only take one or the other. Okay? Because, so circle function, you can only write it as x squared plus y squared equals r squared. That doesn't have any square roots. But if you rewrite it to make y the subject, then you will have a square root. That's why then they call it a semicircle.
Yeah, but we do full circles.
Yeah, and the full circle is this one. It's just that your calculator,
I know, but
yeah, your calculator only types it where y is the subject.
Can you show me the equation?
But it is a function though.
Can you show me the equation of the opposite?
No, I'm going to go back to that later. I'm going to do 5C because we're up to 5C. Yeah, if you're behind, then we can do that later. All right, so for today's session, what I wanted you to take out as your terminology was a function is when you only have one unique y value, okay? Now, if you have a look, all the functions you've learned, a straight line equation, every x value, if you look at it, it only has one y coordinate for it. That's a straight line. If I draw a quadratic equation, same thing. There's only one y value. Doesn't matter how many x's. I got 2 x's here, but I only get one y value. That makes it a function. Okay? But as soon as you get 2 y values, which the example I gave you was a square root relation, this one has 2 y values. See how there's 2 y values there? That kind of graph is not a function. We call this a relation. Okay? Because that has this y value at this point, but for the same point, I can also have another y value at x value. Okay, so this is called a relation. And then all you have to do, in this case here, what they found out is the pattern. One test that you can do that makes it easier for yourself is, how do you know if it's a relation or function? You do what we call a vertical line test. See, if you draw a vertical line down and it crosses twice, okay, if you do a vertical line test and it crosses twice, just listen to the words I'm saying, yeah? If it crosses twice, it's a relation. Okay, if it crosses once, it's a function. Okay, so I'm just telling you, this is not what they've done.
So you mean the coordinate if the coordinate touch each other is function?
Yep, so if I draw a cubic graph, for example, let's do a cubic graph. See, that's a cubic graph, true?
Yeah.
If you want to know if it's a function or not, do a vertical test. Do a vertical line test. I'm going to do a vertical line test. Crosses once, that's a function. Crosses once, still a function. Crosses once, still a function. That's why we call it a cubic function, not a cubic relation. Okay? Let's try another one. What's another function that you learnt? You learnt a rectangular hyperbola. Let's sketch that graph. See, if I sketch a rectangular hyperbola, it looks like this. Let's test if it's a function or not. So it's a rectangular hyperbola. Is it a function? Do a vertical line test. Here we go. I draw a vertical line test. Crosses once. I draw a vertical line test. Crosses once. I draw another vertical line test. Still crosses once. This is a function. If I drew a graph where it looks like this, like I showed you before, a vertical line test in this one will prove this is a relation. What other relations can you have? You can have a graph that looks like actually a semicircle on the side. This is a relation. Okay, so this is a relation in the sense that when you draw it down, it's a semicircle relation. That crosses twice. Okay, so vertical line test will help you determine, so I want you to write that down as part of your notes. Vertical line test will test if it's a function or a relation. Okay, because in the next exercise, you'll do a horizontal line test. Okay? But this is what I want you to write down. Vertical line test will tell you if it intersects once, maximum once, it's a relation or a function. If it crosses twice, it's a relation. If it crosses once, it's a function. Okay? That's pretty much the gist of today. Is just we're going to work on drawing graphs and doing the domains and whatnot, but that's the gist of what you need to understand. Okay? And then I'm going to teach you how to write function notation as well, just learning how to use the notations that we have for year 12. But here we go. Let's do a bit of, oh, no, you were writing notes, sorry. I was going to use your knowledge to tell me which one of the next graphs on the next page, which one of those are functions and which one of those are relations. Ian, we already said no phone in my class. Don't throw it.
Hey, actually,
Just walk over here and give it to me.
actually, I was thinking of something.
Just walk over here and give it to me. Right here. It's not like I'm going to touch it or anything. I'm just leaving it here. Thank you. Just going to leave it here. All right. Here we go. Next page. There's a bunch of graphs there. Some of them are just a bit weird, whatnot. I want you to tell me which one of those is a function and how do you know. So let's look at 2A. Will, is this a function or is it not a function?
Yes.
Yes, it is, because as we do a vertical line test, you can see it only crosses once. Yes, it is a function. Next one, B. Is this a function, Simone? No, this is a relation. Because it crosses twice. We can see that it crosses twice. That's a relation. Next one is C. A function or relation, Trent?
It's a relation.
It is not a relation. It is a function because when you draw it down, it crosses once. It's a function. Next one, G. Is this a function or relation, Najma? Function. When you draw a vertical line test, it is only crossing once. It's a function. Next one, D. Is this a function or relation, Anne? Function, because when you draw down the line, it's a semicircle, but this semicircle is a function. What about the E? Is this a function or relation, Lauren? Relation. Again, it crosses twice. This is a relation. What about F, Steph? Function. When you draw a vertical line test, you can see it only crosses once. This is a function. Technically, that's a sine function. It's likely to be which you'll learn in term 3. Okay? Next one, H. Is this a function or relation, Hamish? Relation. This is a relation, crosses twice. Was that easy? Okay, so logically, you have to be able to look at a graph and tell if it's a function or a relation. Now, number 2, this is a bit trickier, but if you think about it logically or picture it, it's easy to do. Now, What about coordinates? There's one thing that you can look at, and you can write this as a tip. But how do you know? Just by looking at the coordinates, you can sketch it if you want. Looking at these coordinates. So this is group of coordinates is a relation. But if these group of coordinates have a special thing where all the y values are the same, like individual, then we can say that this is a function or a relation. So let's have a look at the first one. A. -3, -4. I'm going to plot it in so you can see. -3, -4. It's down here. -1, -1 is over here. -6, 7 is up. Where's -6, 7? I don't have 7. I'll just do it here. 7. And then 1, 5. Is this a relation? Or is it a function? It is a function. It's a function. Because for every y value, think about it. 7 doesn't have any other 7s. 5 doesn't have any other 5s. -1 doesn't have any other 1s. It's very unique. Every one of them have only a unique y value, y value, y value, y value. Yeah? Let's have a look at B. Let's look at B. Remember, function has a unique y value, Ian. Okay? Next one, let's have a look at B. -4, 1. So I write down -4, 1. That's 1 point here. -4, -1. -4, -1 is down here. And then I've got, what's the other one? -6, 7. -6, 7 is up here. And -6, 8, which is a bit further up here. Okay? Is this a function or a relation? Relation. But you can see that when I do a vertical line test, it's going to cross twice, whereas every other one before was only going to cross once. Now, what's a quick way of sort of picturing this rather than drawing it? Because drawing it takes a while to see. What do you notice the pattern? Yes. Now, which coordinates? Good. That's the tip. If you're doing these kind of questions, the tip is, how do you know it's a function or relation? Just look out for any repeated x values. Because if you have repeated x values, it means when you sub in -4, you get 2 y values, which is not a function. We said when we put it into the machine, it should only spit out 1 value. Now when I put in -4, I get 2 possible values. I can get 1 or -1. That's not what I want. That's not the machine I want. The machine that takes it as a function is when you put in a number, you get 1 number. Or you put 2 numbers, you get 1 number. Okay?
How about like if it's like 12% x is set but up to the like half like if 12% x is set but not 2% x.
Doesn't matter about the x accepts. We're just talking about whether it has the same y values, like yeah? Just copy my notes. Yeah? Copy my notes there. When I say there's a repeated x, notice here that's -4, -4. As soon as you see 2 negative x values in different y values, that's an indicator that it is a relation, not a function. Okay? If you draw the picture of the machine, it makes sense as well. See, if this is the function, if I sub in a -4, -4, you can see already it comes out as either you can get 1 or you can get -1. That's not a function. Because the definition of function, we said it has to have 1 unique y value. That's not unique. That's 2. Okay, so because of that, that's our definition. Okay, it's just a definition. You just got to roll with it. Okay, so we're drawing the graphs. We can tell if it's a function or it's a relation. If it's a function, when you sketch it, it's easier to see. It's nicer to see. That's all. Okay. All right, here we go. So now you know what a function is. The last part is pretty easy. Okay.
How does it come up?
Because the coordinates are there, Ian. Look at the coordinates. What does it say here?
Repeated.
No, I'm just saying that's your x value. What's this value? Is that your y? So when I sub in x equals -4, I get y equals 1. But when I sub in x equals -4 here, what's this one? Yeah, that's where I got it from. Does that make sense? Oh yeah. Oh yeah. All right, here we go. Let's have a look at 1A, B, C, D. Your turn. Is the first one, 1A, a function or a relation? There's only one tip that you got to look for. Rachel, is 1A a relation or a function? A relation. How did you know that it was a relation? Can I please have... Let's go Olympia. How did Rachel know it's a relation?
Because there are 2 same x.
No, innocent. X coordinates. Fantastic, because you've got repeated x coordinates there. 2 zeros, so that means in your machine, if you put in x equals 0, you get two possible values. You get y equals 1, or you can get y equals 2. That's not the definition of a function. Function can only have one y value, okay? So that's a relation. Let's have a look at the next one. B, is B a relation or a function? Ben? A function, fantastic. Every x value is unique. So that means that all the y values are going to be unique as well, or at least it doesn't matter, it doesn't cross. If you do the vertical line test, it won't cross twice, okay? So this is a function. Next one, is C a function or a relation? Finn? It is a relation. Why is it a relation? Good. It has two repeated x values there. Again, if I sub in 0, x equals 0 into the function or the machine, I can get 1 or I can get 2. That's not what I want. I only want one value. Okay, so that makes it in this case here, it's a relation. Okay, and the last one, D, Ian, is this a function or is it a relation?
A function.
It is a function. All the x values are different, so you know that they're not going to cross paths there. If you plot it all onto a graph, you'll know that it ends up being a function. Easy? Okay. Now, once you know how to do the function, the second part, like that second question there is just sketching. That's 5B again. So you can practice 5B in that one. But let's have a look at this one. What I'm going to teach you now is to work with how to write this as what we call function notation. That's your last notes for today. Okay? And then I'll check your homework. So, function notation. In year 12, the way they lay out the questions, and when they ask you to find a rule, there are two things you have to write down. So you can't write y equals anymore. In year 11 and 12, we start to use what we call f of x, or g of x, or h of x. You have to get used to using function notation. Now, y equals root of x minus 1. Let's recap on your memory. What does the x minus 1 do to the graph again? Let's go with, yes, Trent.
It makes it a square relation, which means it's like a root square root. So it's like a line that moves towards the origin, or away from the origin.
Good, like that. But what does the x minus 1 do?
It moves it right one.
Fantastic. It moves to the right by 1. For those who forgot, let it equal to 0. Solve for x equals 1. That tells you it moves to the right by 1. So my graph now moves to the right by 1, and it's a positive square root. So this is what it looks like. Okay, so this is exercise 4C. That's your square root function. Now, if I asked you that, is this a function or is it a relation? What is it? Function. Vertical line test shows me that it's a function. Now, what you want to do today is you want to write this function notation. Now, in order to do that, you got to do what we call the domain and range. You got to find that out first. Okay?
How hard?
No, that's easy. Here we go. Maximal domain or implied domain is all the same things. Okay? They just want you to tell us what the domain of this graph is. Implied means they don't tell you, and you have to sketch it and figure it out. Maximal domain means like, what's the possible domain? So it's the same thing, yeah? Now looking at the graph, you've drawn it. What's the domain of this graph right now? If you have to write the interval notation. What's my domain? What's my domain? It is starting at 1, so x can be 1, but what can else x be? It can't be 0, because 0 is over here. Yeah, and that's it. So the answer to the maximal domain, which is exercise 5B, working out domain and range, it started at 1, and it could be anything bigger than 1. So you can say this, you can either say x is 1 or bigger than 1. But we don't want to write it as x greater than or equal to 1 anymore. We're trying to use interval notation. That was 5B. How do I change x greater than or equal to 1 into an interval notation? Remember those brackets? I want to use those brackets. How do you do that again? How do you say 1 or more? 1 or more. Let's go with Matt.
1 with the open bracket that's on. And then you put a infinity.
Yep.
With the closed bracket.
Oh, it's the other way around. Infinity is always open brackets because we're saying we can't include something we don't know. But then 1, you can see that they do include 1 here. There is a 1 in that equation. So that's why you do include it. And to show that you include it, it's a closed bracket. Okay, so this is exercise 5B for you guys to revise on. that means include the 1, that's the smallest number, to the largest number is infinity, open brackets. Okay? Now we want to talk about domain. Normally the better way is to do x element of. Okay, but right now I'm just going to stick with 1 to infinity. What about the range? Look at the range, look at the graph. My y values. What's my maximum and minimum y value of this graph? 0 is the minimum. What's my maximum? Infinite. It goes on infinitely up. So if I were to write the range, up, this is positive, yeah? So, if I were to write the range, does it include 0? Yes or no? Yes. So we do close brackets. We don't ever include infinity, so we say open brackets. Okay, so that's your domain range. That's exercise 5B. Now 5C today, this is what you're going to do. We're going to write function notation. This is how we start off. If you're going to call your graph f of x, you would use f, you type out f colon. So copy this formula down because that's how we write it. Okay, it's just the language, how we display it. We do f colon, then we write in the domain. So the domain right now is 1 to infinity, open brackets. This is new for you guys. The arrow means maps onto R, and we put a comma. Now in methods, you're not going to have to worry about all this. This will always be maps onto R. So you can always remember it maps onto R. If you're wondering what it means that you're taking this interval and you're sketching it on a plane, because this is a plane of numbers. What are those numbers? They're any numbers that you think of. So you're taking out 1 to infinity out of the set of numbers that you have. And the numbers that we have right now is R. But you see, if we're not working with numbers, we're talking about grabbing a group of chairs, or let's say cars. Let's say I have Mercedes, I have, I don't know, what are the Toyota, Mazda, yeah? Okay, I've got all those kind of brands. Well then, will be mapped onto cars. So this will be called cars. Because that's just the group of things that I'm working with. And what have I taken out of that? I'm taking out numbers from the group of numbers. I'm taking different brands of cars out of cars. But because we're working in methods, the only numbers you work with is R. Unless you're in Spesh, then you work with complex numbers. And that would change the C and whatnot. But in our case, it's always going to be arrow R. Okay? Now, once you do that, the last part is easy. Instead of writing y equals to root of x, we write f of x equals to root of x minus 1. Okay, so what this tells you, this is called a function notation. And this is how you expect it to write it in year 12. When in year 12 they ask you to find the inverse function, or define the function, or solve the equation, that's what you're meant to write. It's a 2-mark question, because you have to have the domain, and you have to have the correct labeling. You don't use y anymore. The only time you use y is if they give you y. Okay, so if you use g of x, that'll be g. Okay, and whatever the domain is, you have to find it. That's what they're trying to find out in year 12, whether you can find a domain or not. Okay, so domain maps onto R, arrow R, function. Now that function could be anything. It could be h of x, g of x, whatever it is. Root of x minus 1 was there. So we don't use the y anymore. Sorry? Yeah, they're just different functions. So you can have g functions, you can have h functions, you can have t functions. You can call it whatever you want. Yeah? But I'm just saying, if you use the letter f of x, this will be f here. Okay?
What do you mean by
Arrow means to draw onto or map onto. That's the domain. This is the letter that you're using. That's the domain. That's numbers. Just copy it. That's all you got to do. Yeah? Domain always maps to R. Function. Functions, yeah.
So there's a formula, right?
It's just how you're meant to write your answers. Okay? All right. Let's do an example. Let's do an example so you get used to this. Here we go. Let's try this one. So, example 10. Quiet down. Last part for today. It says rewrite each of the following using function notation. That's what it means here. Okay, so f colon x maps to y notation really is just saying function notation. Okay, so don't get confused by that. That just means find function notation. Now, if you look at this first equation here, if you read it, it says you've got a group of coordinates that follows this equation. Now you got the equation already. Now you don't have to use F. You can use G or H or T or whatever letter you want. So I'm going to use a different letter now. I'm going to call it T, okay, for Mr. Tran, right? So I'm going to do T, colon, for A. I'm going to do A. Now what's the domain of this graph here? That's a linear graph there. Negative 3x plus 2. What's the domain of a linear graph? You can sketch it if you want as well. Negative 3x plus 2. Anyone know what it looks like? What's the y-intercept? 2. So I got 2. What's the x-intercept? 2 over 3. Whoa. 2 over 3. And we know it's a linear equation, so I'll just draw it. This is what it looks like. Now you tell me, what's the domain of this graph?
What the domain?
Domain.
Domain's y.
Domain's x.
The maximal axis is infinity.
No. See, every graph here,
Negative.
not 2/3. It is technically every number that you can think of. See, like if I chose a number over here, I get a coordinate. If I chose a number over here, I get coordinates. If you look on the x-axis, where does the graph go? The graph goes infinitely out, so you can infinitely choose a point on the x-axis. Just R. So the domain right now, domain of this graph is R. So now if you were to write the function notation, which let me just highlight for you so you can see, it's common that a lot of students think that the domain is the x-intercept. It's not the x-intercept. It's just where does the graph stop? It doesn't stop, it keeps going. You're just trying to find what x values you can cover. See, if I kept drawing this and it goes on, every one of these x coordinates will have part of the graph. That's why we say it's R. Okay, because we're saying it keeps going down, so all these x values here will have a coordinate. And this keeps going on, all these x values have a coordinate on the graph. Yeah? Unless you stop it, if you draw the graph like I did at the start, that restricts it. Okay? So here we go. We now know the domain is R. Let's write our function notation. Function notation, what comes first again? I got T. What's the next one? What do I write after I write T colon or F colon? R, good, because that's my domain. And then? Not the comma. Maps onto R, good, and it's always going to be maps to R, comma. T of X equals? Fantastic, done. That's called function notation. Yeah, I'm running out of batteries. But this is called function notation. You got your domain, maps to R, T of X. Because that doesn't have to be T. It can be any letter you want. Let's try the next one. Let's do B. Let's do B. Ian, have you noticed every second session you say what the hell? Let's do the next one. Let's have a look at this. You got a set of coordinates where this is the function. It's a linear equation again. But in this case, they tell you x is greater than or equal to 0. What is that telling you there? Why does it tell you x is greater than or equal to 0? What have they told you just now? Yeah, exactly. They just told you the domain. Literally, they've told you the domain. You don't have to do anything now. Now, how do you write x greater than or equal to 0 as an interval notation? How do you write this as an interval notation? Interval notation. Let's go, Finn. X is greater than or equal to 0. How do I change that to an interval notation?
Wait, which one?
This one.
Yeah. So it's zero.
Yep.
Including square bracket.
Good. Fantastic. Good. That's your domain. So now if you were to write your function, it doesn't have to be F. It could be G. G colon. Write down the domain. 0 to infinity. Maps onto R. G of X equals to negative 2x plus 5. Does that make sense? Those are the two skills today. I just wanted to teach what a function is and how to write a function notation. You can? Yeah. It could be any letter. Doesn't matter what the letter is. And we use X because that is X.
Yeah, I know.
If that was A, would you say A? Excellent. I'm going to pause the video and then we'll call out your names. You're going to come up. None of you are leaving until I tick off all your names and those who haven't done their work. Start at the bottom.
I've done it.